So today we're going to step away from geometry and we're going to solve this interesting Cambridge entrance exam question, which states to find all integer solutions of the equation p to the power of 3, which equals q to the power of 3 plus 2q squared minus 1. This interesting question was sent to me by one of my subscribers, Randy. Randy stated that this was actually a Cambridge entrance exam question and he wanted to see the solution. So I have done my homework for this one and I actually checked and found that this indeed was the question from the University of Cambridge STEP 2011. So thank you, Randy, for this wonderful suggestion. Of course, you guys can try this out for yourself. But be aware, as Randy stated, you need to have a firm proof for your solution. So you can't just put random numbers there and hope for the best. So, if you want to try this one, this would be a great time to pause the video and then come back and check the solution. Alright, so let's solve this one. First, I'm going to color grade the P and Q. I'm going to put P in blue and Q in red color so that you can follow the steps more easily. And as we said, P and Q must be integers. So since throughout my math career I have done many of these problems, I know exactly what to look for. And this is exactly what I'm going to show you. I'm going to show you how to approach this problem and to solve it with ease. So we have to think about the terms in which P and Q are integers. Or, to be more precise, we're going to think when P and Q are not integers. And when we find those terms, we're just going to do the antiterm for them and see when P and Q are integers. Let's try it out. So, if, for example, q is an integer and we say that we can put p in between q and q plus 1, this is actually false. Why? Because the fact is that if both of them are integers, we cannot meet those conditions, because there is no integer strictly between two consecutive integers. So let's use this as our condition and try to find when P and Q are actually not an integers. First, we're going to split this into two separate conditions. As you can see, for first one, we have that P is greater than Q, and for the second one, that P is lesser than Q plus 1. And let's concentrate on the one on the left side first. So we're going to put everything to the power of 3, since our original equation is to the power of 3. So if we do this, we're going to get the following. Now you're probably wondering, can we actually do this because we do not know the signs of P and Q? Well, actually, it doesn't matter, because if you put any number with the sign plus or minus to the power of the odd number, you will get the same sign. So we can safely put this to the power of 3. Now we're just going to substitute the value of p to the power of 3 from our original equation and we will get the following. Now we will cancel q to the power of 3 on the both sides and we are left with this really nice quadratic inequality. So you can find the values for q in multiple ways, but I'm going to choose to find those values by using the quadratic formula, which states that if we have a quadratic equation in terms of ax squared plus bx plus c that is equal to 0, then we can use the following quadratic equation to find the values for x. We're just going to use the same thing. As you can see, for our quadratic inequality, a is equal to 2, we do not have the b, so it's 0, and c is equal to minus 1. And we're going to implement those values into our quadratic formula and get the following. Now we're just going to simplify this a little bit and calculate, and after simplifying square root of 8, we will get that the values for q are plus and minus square root of 2 over 2. So for the better understanding, let's draw the function. So we will put those values of minus square root of 2 over 2 and plus square root of 2 over 2 on the x-axis. And since we know that a is equal to 2, which is greater than 0, this means that our function must be a happy function and it looks like a smiley. So if you take a look at our quadratic inequality, you can see that it is greater than 0. So this means that our solutions will be in the positive specter. So this means that q must be inside the range of minus infinity minus square root of 2 over 2 and square root of 2 over 2 to plus infinity. Alright, so now we have the range for our left side, and let's try to find the range for the right side. We're going to do the similar thing here. We're going to put everything to the power of 3, and of course, as in our previous problem, we can do this easily because we're putting everything to the power of the odd number, so signs will be the same. So, we're going to get the following. Now we will implement the value of p to the power of 3 from our original equation, and we're going to expand our right side by using the formula for the cube of binomial, which I'm going to leave you on the left side. Now, if we do this, we're going to get the following. We can now simplify q to the power of 3, and when we rearrange our terms, we're going to get this beautiful quadratic inequality. And for the sake of consistency, I'm going to find those zeros for q by using the quadratic formula again. So you can see that in this case, a is equal to 1, b is equal to 3, and c is equal to 2. And we're going to implement those values into our quadratic formula and get the following. Now we can simplify this, and after simplifying more, we will get minus 3 plus minus 1 over 2, which leads us to two possible solutions. The first one is minus 2 and the second one is minus 1. Again, as before, I'm going to put those values in the x-axis of our quadratic function, and since a is equal to 1, it is also a positive value, so our function is happy function again. And if you take a look at our original inequality, you can see that it is greater than 0, which means that our conditions must be inside the plus value. So those conditions are obviously that q must be in between minus infinity to minus 2 and from minus 1 to plus infinity. And now we have our conditions, but remember, those are conditions when p and q are not an integers. So in order to find the conditions when p and q are actually integers, we need to find the opposite conditions of those that we have. And the opposite condition from the one on the left is that q is in between the range of minus square root of 2 over 2 to plus square root of 2 over 2, and including those two values as well. And the opposite condition for the right side is that q is located in between minus 2 and minus 1, including those two values. So, let's now try to find the integer numbers which match our condition. If we take a look at the left one, the only possible integer in between minus root 2 over 2 and plus root 2 over 2 is actually 0. And for the right side, the only possible integers are minus 2 and minus 1, since both of them are included inside our condition. And as you can see, we now have the values for q. Now let's try to find the values for p. We're just going to substitute the value of q inside our original equation, and if we do this and simplify, we will get that p to the power of 3 is actually minus 1, which means that p is equal to the third root of minus 1, so p is equal to minus 1. We're going to do the same for the second one, and we're going to implement the value of minus 1 instead of q, and calculate this. So we're going to get that p must be the third root of 0, which actually equals to 0. And for the final one, the same thing again. We're going to simplify and get that this is equal to -1, which means that p must be equal to the third root of -1, so p must be equal to -1 again. And those are our corresponding pairs. So we're just going to write this down a little bit more professionally. So the pairs of p and q have the values of -1 and 0, 0 and -1, or -1 and -2, and those are our solutions. So, I hope you guys liked this video. If you did, do not hesitate to leave a like or subscribe to the channel for more content. Of course, if you guys found any other way to solve this problem, please write it down in the comment section below. And tell me what you think about this kind of videos. Should we do more of those in the future? Please tell me your opinion in the comment section. And as always, until next time, see you all and take care.